In our last video here at Blacksmithing Forge, we looked at forging a spoon auger. This is a tool inspired by the Mastermyr find and some of the examples given in this book. It's not an exact reproduction, but it is very similar and will function in very similar ways. Instead of being forge welded out of wrought iron with a tool steel cutting edge, this is a single piece of coil spring. And we left it in the vermiculite to cool. So it has had plenty of time to cool. It's been 3 or 4 days. I've had a lot of other things to work on besides this. But it is now ready to grind. So that's the first thing we need to do is get this ground to shape, polished up somewhat on the back as much as we can. It probably won't be a perfect mirror polish. And then we're going to have to harden it, temper it, sharpen it, put some sort of a handle on it so we can actually use it and try it out and see how it works. So that means we're off to the belt grinder. I've got the backside all cleaned up. The inside of this really doesn't matter. It's not going to do any work on the majority of the inside. It will get a bevel ground on the inside when we sharpen it, but that'll happen later. So most of this you don't have to worry about cleaning up. It's just the back so it runs smoothly as it cuts the hole. All of the work up to this point has been done in the gas forge, so I'm just going to go ahead and keep using the gas forge. Bring this up to heat kind of slowly, let it soak for a little while, and then we're going to quench it in oil. Again, this was made from coil spring. Most automotive coil spring is 5160 or something similar. At least the older stuff is. Newer cars can tend to have more proprietary steels, and it pays to do test pieces. But I've made a lot of tools out of this piece of coil spring, and treating it just like 5160 has worked just fine. So that's what I'm going to do with this. Only need to harden the spoon part. None of this needs to be hardened. This is probably going to take about 15 minutes of running the forge up, turning it off, letting this soak to come up to heat evenly, then bringing it up a little bit more. The slower you bring it up to heat, the better. So I'm not going to make you stand here and watch this for 15 minutes. We'll be back when it's ready to quench. Now I have taken the time to preheat my oil. Just use the hot bar of steel and put it down in there and get the oil good and warm. You get a much better quench with warm oil than you do cold oil. Keep it moving in the oil so that it quenches evenly. I'm not quenching up into the shank. I don't want it hard right there at that transition. That's where it would want to break if it broke. So I want it to be a little bit softer right through here. So that's quenched and it's cool enough you can touch it here. So this is all properly hardened and it's time to go ahead and temper it. This is still kind of warm in here, but I don't think it's hot enough to bleed down here and change my temper. I'm going to go ahead and temper this in the toaster oven like I generally do just because it's efficient and allows me to get onto some other things in the shop. I'm sure the originals would have been tempered by leaving a lot more heat up in this area and letting it bleed down, or perhaps tempered on another block. But I'll get a more reliable temper result if I go ahead and do it in the toaster oven. I get a lot of questions about the oil I use for quenching. The oil I have, I bought from a local supplier. They can get you any kind of petroleum product. I just asked for quenching oil. I have no idea what brand it is. It didn't come with any specs. It probably came out of a 50-gallon drum and just got put into a bucket to give me 5 gallons of it. So I can't tell you exactly what the brand is, what the specs are, but it is a commercial heat treating oil. It's meant for this purpose. There are lots of things out there. There's Parks 50. McMaster Carr sells a couple of different versions of hardening and quenching oils. I'm not sure what the difference is. There's even a Blacksmiths quenching oil out there I've thought about buying when I replace this. And this is kind of old and probably needs to be replaced. It does break down over time after you've used it a whole bunch. Some people like to quench in canola oil or olive oil, something like that. And I'm really tempted to try one of those. That the reason I haven't is, one, they're a food product, and we live in an area with lots of critters, and I don't really need bears, raccoons, or skunks in the shop checking out my quenching oil and possibly spilling 5 or 10 gallons of it all over the shop floor. But the other reason is that my shop isn't heated in the winter, and those kind of oils set up pretty solid, and it takes quite a bit of time to thaw out that whole bucket of oil and then preheat it. It's much easier when the oil stays liquid like the petroleum oils do. But if I ever get around to insulating the shop and can keep it above freezing in here, I might go to one of those and see how it works. Once that's done in the tempering oven, it will be back to the belt grinder just to polish up that back edge again and remove any scale or discoloration from the hardening and tempering process. Blacksmith Forge is sponsored by Combat Abrasives. You can use the link in the video description and the coupon code BlackBear10 for a discount on your next order. So that's really all we need to do to clean that up. Now it's time to talk about handles. I went ahead and took this down to a 320 grit belt finish. I think that's fine enough. You can go ahead and mirror polish it if you really want to. But our spoon auger is now hardened, tempered, final grinding is done, and it's been roughly sharpened on the belt grinder just using a contact wheel that fit inside this profile. I think that's probably a pretty reliable way to do it. And I think if you were a Viking blacksmith or Viking woodworker making one of these, you probably spent a whole lot of time with a hand stone because they probably didn't have any other way to really get in there. They may have had some rotary stones, but probably didn't have any options that would fit all sorts of different things. But this ends up being just a hair under 1.5 inches wide, so it's really a pretty big auger. I think it's perhaps a little larger here based on the shaft size, and proportions might be a little off, but as long as it works, that is the key thing. The spoon part is a little over 4 inches, and the shank up to where it'll go into a socket is about 8 inches. Now, as far as handles for these go, personally I think the easiest handle would be a T-handle like this particular version of this has, but the ones in the book all had an iron ring around the shaft, and that would imply that it had some sort of an inline handle, more like a chisel, although probably a much larger handle than your typical chisel would have. And that's sort of what they show in the book, although the image in the book on page 35 says that that image is based on the collection from a different museum, so it was not part of this find, just something similar. And it shows an inline handle with a cross piece put through it that looks like it's removable, and a piece on top that looks like it pivots, so you could put this up against your chest and turn, and if you're drilling in big timbers, that probably really helps to have that pressure. You can lean into it, although it looks like there's a tenon sticking up out of the top of that breast piece, and that'd be pretty uncomfortable, but probably pretty historically accurate because these were probably used for building ships. As you look online at some of these other people have done, that's the style of handle they usually put on there. And I found some images online. I haven't been able to look at the real pieces, but the pictures from 16th and 17th century spoon augers show very similar handles. Some of them look like it had a piece that might have turned on top. A lot of them just had a great big knob on top, so if you leaned into it, it would turn against your chest, but it wouldn't be a sharp thing that would be uncomfortable. And I think that might be a pretty reasonable way to go as well. No way of knowing 100% for sure, but I think I'm going to kind of go for the inline handle with a cross piece, but not with the rotating breastplate on the top to lean up against. I think that's just a little further than I need to go with this piece at this point. Now, when we look at this one, this is actually an old spoon auger. My guess is it's not anywhere near that old, 100 years old, 150 maybe. And you can tell that it's made out of wrought iron. You can see some of the grain, and you can see a little bit of a cold shut running down the middle of the wrought iron where it's been forged down out of a bigger piece. And you can see a very telltale sign of the scar from a forge weld. So this part is wrought iron, this part is steel, and it's been wedged into the handle. And actually looks like this is a replacement handle because it's got a punched hole that would have had a wedge going crossways this way, but it's gone and there's no sign that that was ever rubbing up against this handle. Instead, it's got a wooden wedge down either side, and that's holding it very nicely. So personally, I think this looks like a real practical way to go, but doesn't seem to be consistent with what I'm seeing in the book and other examples, especially when you find the presence of the iron ring. By the way, the iron ring is just a piece of tubing that I cut off, blackened in the forge, nothing special. I didn't forge weld this. I'm sure the originals were wrapped and forge welded though. So what am I going to make this out of? I'm going to see if this piece of birch out of the firewood pile has enough decent wood in it. It's got a whole lot of checking at the top, so if it's too cracked and I can't get a good billet split out of this, I'll have to find something else. But I don't have lots of suitable woods around for making big handles like this. I think because of all the knots in this, I'm going to split it with a steel wedge. Let's go ahead and clean that up with a froe. That's going to be close. It might be a little bit on the small side. Let's see what this other piece looks like. I think all in all this looks better, even though it's got this place where the knot was. But it does not have as much checking, and it's a little bit bigger. So I think we're going to go with that. First thing I want to do is just kind of square it up. I wouldn't mind planing this square, but there are no planes shown in the book, so I'll do it with a draw knife. There are draw knives shown. I just want to get it down to a point we can cut a slot in it. I'm going to make this the end that it inserts in. I think I'll put the little crossbar in through here. I'm not using any kind of a square just because this is not square. So I'm kind of eyeballing the odd angles and not worrying too much about exact straight lines, but because they came out the same, I think I probably went pretty straight all the way around. Using my fingers as a little guide there, space between those two lines should be centered. Some of these earlier spoon bits that I've done were meant to go in a bit and brace. So that's just what I'm going to use to drill this, just to see how these work. A little hard to get started, as I recall. One of the advantages of a spoon bit is that you can steer it back on line a little bit if you need to. There's no doubt this could be sharper. I'm going to start this side with a little gouge. Probably bore a hole all the way through just like that if you needed to. Okay, there we have a fairly decent little slot in there. With the slot in here, the next thing I want to do is go ahead and round this up. I think it could be octagonal if you liked an octagonal handle. But a little quick research shows that wood turning predates the Viking age. So I'm going to go ahead and turn this. I don't have a nice Viking era pole lathe, but I do have a lathe. So I think I'm going to just knock the corners off, get it ready to turn, and then go to the lathe. This birch is working so easily, I have some concerns that it may be too soft to really make a good handle for this. So someday I'll have to find a nice piece of maple or something. Maybe white oak would be good. I'm going to start roughing this out with this big roughing gouge. This is one I forged. It's one of the few tools in my collection that I've actually made myself. There are others here that are clearly hand forged or homemade tools, but there's some I bought as antiques. I'm also going to take the long sleeve shirt off just for safety. So let's put the iron band on there to reinforce that. That should help quite a bit. Then I'm going to have to make a tapered hole. Burning this in would be a really good idea, but since I'm not in the shop, I'm not going to go up there just to heat that and burn that in. No, that's just going to fall into the other hole, I think. I think burning in would definitely be the way to go. This may have to wait till I get to the shop again. But we'll see what we can do here. Now, the birch being soft makes this easier, but I'm still quite concerned about how it's going to hold up. Pretty tight. But it also split this, which I was afraid it was going to. So as I say, this is not going to be a great handle, but it gives you the idea. Then it gets a board in here crossways. If it's a good handle, I'd cut one that fits better than this does. But let's try it out anyways. Well, it shows promise. Of course, working on a bench like this, I can't lean into this, and I think that's really the way these were meant to be used, especially if they were being used by shipbuilders. In some ways, I think this is easier, and that may be an advantage to this style handle, but it could be sharper. It's doing a lot of tearing instead of cutting. I may have to do some research on the best way to sharpen these. Modern techniques, I think a Dremel might be the way to get in there, or some other rotary shaft tool. But I expect for Viking it was just hand stones. So this shows real promise as a functional tool. It's too bad the handle split, but I had my doubts about this birch holding up in the long run anyways. Too bad, it's really a pretty piece of wood. But at some point I'll make a new handle. We'll look at maybe doing another one of these out of wrought iron with a tool steel cutting edge, so it's a little bit more traditional from the Viking point of view. And hopefully then I will have figured the handles out and figured out how to sharpen them a little bit better. And then hopefully we can take a little bit more realistic look at the way these things really function. In the meantime, I hope you have time in your day to get out to your shop, but be safe, wear your safety glasses. We'll see you for the next one.